Okay, so in this problem here, we have to determine whether the variables show direct, inverse, or neither. Okay, direct variation is y equals ax, or when you want the constant of variation a, you can do y divided by x. That's direct. Inverse, this is direct. Okay, inverse variation, you have y equals a divided by x, which means if you solve for a, because that's a constant of variation, you get x times y. Now, if neither of those work, if you can't get the same a every time you do one or the other, okay, I want to check that and check that with my variables. If neither of those versions of a are the same every time for all the data you're given, then you have neither. It's some other growth pattern, but it's not direct or inverse. So let's check for direct. Okay, when we do this, I get 36 divided by 2, which is 18. Then I get 24 divided by 3. Oh, that's 8. That means this a is not constant for direct variation. So let's try it for inverse variation. So I got 36 times 2, which is 72. I get 24 times 3, which is 72. So far, so good. 18 times 4, which is 72. 12 times 6, which is 72. 9 times 8, which is 72. It works. So I would say this is inverse variation. And what did I get every time I multiplied? Well, these are a's. So my a value is 72. So I know it's inverse variation. I'm done. Okay, this is number 2 on the part of the test that you could do long answers for. And it says, to find the circumference of a circle given its area, you could use the following formula. So we're supposed to write a sentence using the variation terminology to describe the relationship between the circumference of a circle and its area. Well, in the most basic form, this is c equals some constant times the square root. Oh, I don't like that. Times the square root of a. So what is that constant here? Well, the constants here, 2 never changed. 2 never changed, and the root pi never changed. So those are our constants. So they don't really care about the constants. You don't have to write anything about the constants. You can if you want, but that's not required in the problem. So, and does it look like this kind of form? It has this basic form of direct variation where you go at y equals ax. In this case, it's y equals a square root of x is what we're looking at. So, okay, pretty easy now. So I'm going to say the circumference varies directly, or you could say is directly proportional to the, now this is key, it's not just directly proportional to a, it's directly proportional to the square root of the area. And that's essentially it. So it could be the circumference varies directly to the square root of the area, or the circumference is directly proportional to the square root of the area. Those are just as good. Some people talk about the constant of variation is 2 root pi, and there's some other ways you could have said it, but this is the simplest way to do that. Okay, so this is quite wordy, so we're going to just read it and then we'll come back and break it down. The strength of a magnetic field around a wire, which is measured in Tesla, is directly proportional, that's a key word, directly proportional, to the current as measured in amps, and inversely proportional, that's another key word, or words, to the distance from the center of the wire. Let's say you use a magnetometer to measure the strength of the magnetic field around one of the electrical wires that forms the Gordian knot of cables connecting your home theater to the overburdened electrical outlet. If the second reading of the magnetometer was taken at half the distance to the wire than the first reading, how much stronger was the second reading than the first reading? Well, that's a mouthful. So let's go back and remember we got these two basic ideas. Direct variation or directly proportional is going to look basically like this: y equals some constant times x, and inverse is going to look like y equals a over x. Again, they could have other adjectives to change powers or square roots and stuff, but that's the basic ideas. Okay, so this is direct, and this is the inverse. So let's just see what we start with. It says the strength of the magnetic field is, that's T. I'm just going to call it T. You can call it M for magnetic field or something like that. It says is directly proportional. Now, that means I've got this here, A, and what is it directly proportional to? The current. I chose to use I. In physics, I remember my physics, we used I as the current. So if I stop there, the magnetic field is directly proportional to the current. There it is. But it goes on to say, and inversely proportional to the distance. Well, I already have a constant there of variation, so that could capture any of this other stuff. And the distance is right here. Okay, so that's our basic formula. If you did that, I usually gave you half the credit because you understood how to read the problem. But they really want you to solve it. So let's say we have that formula, and now you're going to make a measurement. Everything's the same, you believe, except that now the distance was half the original distance. Okay? Well, how do I solve that thing? Well, it's basically the same stuff we had. Whoops, that doesn't look like it. With an extra half on the bottom. 1 over 1/2. That's what it looks like here. That's how you could write that red half. Okay, but when you divide by a fraction, you have to flip it and turn it to multiplying. So this would turn into what we started with on the first reading, and this would change to 2. The only thing different is it's got a 2 times everything. Well, that means it's double. The reading will be double. Double the first.